All right, guys, Mr. Antonucci here, and in this video, we're going to go over repeated use of the chain rule. And at the end, make sure you stay tuned because I'm going to go over an AP style question. So when we're talking about repeated use of the chain rule, this is where you have a composite function that has more than one composition. The example on the screen, you have f of g of h of x. Well, when you do this, you just simply keep applying the chain rule. So if I were to take the actual derivative of this, the outside function is f, and then what's inside that is g of h. Then the inside, g of h, I would take the derivative of g of h of x. Well, the derivative of g of h of x is the derivative of the outside, g prime, of h of x times the derivative of h prime. And this is really illustrating why this is called the chain rule, because you keep having chains of derivatives. Let's look at example here. Now, remember what we taught you, that cosine squared is really squaring the whole cosine function. So if I take the derivative, this is going to be 5 times, the 2 is the exponent, so it's a power function. So the derivative is going to be 2 cosine, technically to the first power, but we don't need to write that, 3x plus 2. Now the cosine was inside the squaring function, so I need to multiply by the derivative of cosine, which is negative sine. Now be careful here as well, because if you don't write parentheses, it could look like you're subtracting it. So parentheses are important there. 3x plus 2, and the inside of the sine is 3x plus 2, so its derivative is 3. Now, if we clean this all up, the 5, the 2, the negative, and the 3 can all multiply and give you negative 30 cosine of 3x plus 2 times sine of 3x plus 2. Now for this one, similar thing going on. You have sine cubed of pi over 2x. The cubic function is the outside, sine is inside that, and then inside of sine is pi over 2x. So when we take the derivative, the outer function, the outermost function is the cubic, which is a power function. So there'll be 3 sine squared pi over 2x times the derivative of sine, which is cosine, with the inside of that still there, times the derivative of the inside of cosine pi over 2x, which is just pi over 2. And then you can clean this up by multiplying the constants together. There you have it. Now, this last one here looks pretty crazy. However, if you remember one key thing, natural log and e are inverses of one another. So really, the e and the natural log cancel, and this simplifies to 2x plus 1. I did absolutely zero amount of calculus so far. I just simplified the function. Now the derivative is just 2. Now, had we not recognized this and we treated it as a chain rule function, the derivative would be 1 over u, e to the 2x plus 1, times u prime. The derivative of e to the 2x plus 1 is 2 times e to the 2x plus 1, u prime e to the u. And then notice you have e to the 2x plus 1 in the numerator and denominator. They cancel, and you end up with 2 that way. So it still works, but realizing that e and natural log are inverses and therefore going to cancel one another, that really, really helps simplify the problem. Okay, here we are with our AP style question. We want to find the derivative of this function. So here we have a power function on the outside. It's the squaring function. Inside of that is sine, and inside sine is 5 theta. Now that 5/13 out front, don't let that bother you, because that's just a constant that can multiply our whole answer. So f prime of theta is going to be 5/13 times 2 sine, technically to the first power, but we don't need to write that, of 5 theta. I like to put my 5 theta in parentheses. The inside of that is sine, so I have to take the derivative of that, cosine, of 5 theta, and then the derivative of the inside of the cosine, which is 5 theta, so its derivative is 5. To clean this up a bit, you have 5/13, you have the 2, and you have a 5. This is going to be 50/13. So it's not this one. We also have sine 5 theta, cosine 5 theta, which choices C and E don't have those. The only ones that line up kind of are B and D. Notice D has this extra negative here, and that's because sometimes students mix up the derivatives of sine and cosine and which one ends up being negative. But since we took the derivative of sine, its derivative is cosine. The correct choice here is B. All right, guys, that's it for this one. Hope that was helpful to you. Let me know in the comments if this was, and make sure you subscribe to the channel if you haven't for more videos.